Hello everyone, I am Ravi Shankar Pal from ABES Engineering College Ghaziabad. In this video lecture, I am going to discuss about the address calculation of one-dimensional array. In this video lecture, I am going to calculate how to find out the address of a particular location of an element in one-dimensional array. So let's start. First, we know what is base address in the one-dimensional array. Basically, if we represent one-dimensional array in memory form, it look like this is the name of array. Here, suppose its base address is 100. We have supposed it, not it is basically 100. It is hexadecimal number. And if we assume that the one cell take space of 1 byte, then next address will be 101, and similarly it will locate contiguous memory location. This is the specialization of the array to store the element in the memory. Okay, means what is base address? Basically, this is the base address. Base address means address of first index or first element stored in memory in one-dimensional array. So here, what is base address? Address of first element in an array is called base address. And array elements are stored contiguously. I already told contiguous means one and after another. Means if first element is stored here, 100 location, the next will be must store at the just one address difference, 1 byte difference to the starting address. If we assume that one cell contains the 1 byte. So there is no need to keep track of address of each element. What is the meaning of this? Means if you want to access this element, this is the suppose index 0, starting index we assume that 0, and this is 1, this is 2, this is 3, 4, 5. This is suppose this is the indexing in the one-dimensional array, and we start indexing with the 0. Then what is the meaning of this line? This line says if you want to find the address of element stored at third index, then we can directly access this element. This is called random access. This is called random access. This is the advantage of array in comparison to linked list, where elements are stored at different scattered positions. So if you want to access address of any particular elements at any location, then we can directly go to the address of that element without going to track each address starting from the first element. This is called random access of the elements in one-dimensional array. So we only need to know the base address of an array. Means if you want to access any element in one-dimensional array, then we have must the address of first element only. That is called base address. If you have base address, then we can find the element of the address of any element in the array. So to find the address of any element in one-dimensional array, we can find the formula that is called base address. Means we have base address, then we have the index. I is here index. If you know the index of the element, whether it is stored, and if we know the size of particular cell, E is size means if an element is of integer type, suppose, then we assume that it one element take 2 bytes to store in a memory cell. So here it is the data type of array same, the size of an element. This is the formula to find the address when array index is starting with 0. Already told that if array first index is start with 0, then this formula will be effective. For example, suppose we have an array of A and we find the index 3 location of the index 3 element, and if data type of an array is integer, means the element stored in array is of integer type, then suppose it takes 2 bytes or 4 bytes, whatever you will assume, and it is given that base address is 100. Base address means the address of first element is given here, that is 100. So next element is at contiguous location, means if here it is here we assume integer takes 4 bytes, means one cell, yeah, size of one element is 4 bytes. Okay, then how to calculate the size A3? A3 means there are total 4 size, yeah, 4 elements in the array starting with 0 index, 0, 1, 2, 3, like that, and this is represented in index form, that is A0, similarly A1, A2 and A3, and the if address base address is 100, then the address of this one is 100 and address of this one is 104, similarly 108 and 112. Okay, now how to formulate the at to how to find the formula to find the address of any particular element located at index I in the one dimensional array. The first, you must know what is lower bound, what is upper bound in a given array index. So what is lower bound? Lower bound is basically starting index of the array, and upper bound is the last index of an array. These two you will must know to find out the address of any particular location of an one dimensional array. Here, look, if you want to find the total, if you don't know the size of an array and you have the lower bound, you have the lower bound and you have also given the upper bound. In this array you can see that lower bound is -1, upper bound is 2, then you can find out the total number of elements in array, means how many elements are in the are there in the array, means simply subtract upper bound, subtract lower bound from upper bound plus 1. So what will be the size of the array? This is also known as number of elements in the array. That is here 2 is the upper bound minus 1 is the lower bound plus 1. That is 2 plus 1 plus 1. That is 4. There are total 4 elements in the array. Look, first, 2, second and 4. Sorry, first element, second element, third element and 4 element. So if you don't know the size of array or number of elements in array, you can directly find out the number of elements in array if you have given lower bound and upper bound of one dimensional array. So first you know the what is the starting index of array, that is called effective index of array. So if array index is not start with the 0 index, it will start with another index like 1, 2, 3, 4, 5, 6. Then first you will find out the effective starting index. Starting, suppose we know the starting index with name lower bound, then effective index is called I minus lower bound. So what will be the address of an element stored at ith index is, you have already base address If you don't have given base address, that is the name of the array is base address. Okay, base address plus effective index. If not started with 0, then I minus lower bound. If you have know the first index name as lower bound, then doesn't matter whether it is start with 0, it is start with -1 or any other value. Simply you have the index of the array which you have to find out the address, and simply minus the first lower bound means starting index of the array, and multiply by size of an element. Means if the size of one element, that is, it depends on the data type of element, it is 2 bytes, then multiply by 2 bytes. It is 4 bytes, then multiply by 4 bytes. If one element takes 6 bytes, then multiply by 6. For example, now if our formula to find out the location of a particular element in an array is base address plus index of element minus starting index, that is represented a lower bound, multiply by size of an element, that is data type of element. And here if you have given an array A115, what is the meaning of this? Here lower bound is given as 1, 15 is the upper bound is given as 15, and byte per cell is equal to 3, means the size of one cell of memory is 3 byte. Means if this is the base address 1000, the next address is 1003. And similarly in contiguous, this is 6. The meaning of the per cell is 3 byte, means that the size of one cell is 3 byte. Okay, and base address is 1000, address of the first location. So here we have to find out the A9. What is the meaning of A9? A9 means here I is given as 9 and base address is given as base address is 1000. So your formula calculate 1000, that is base address, plus I means the index of the element where it is located, that is 9, minus starting index, that is lower bound. Lower bound is 1, that is 1, multiply by size of an element, that is 3. So here it is 102. This is the location of the ninth element of the array A. So we will take another example here. If you have given an array A, first means you have given a lower bound -1, upper bound is given as 2. This is called starting index. This is called starting index. And if you want to find out the size or total number of elements, you can also find total number of elements in array A is equals to upper bound minus lower bound plus 1, that is 2 minus 1 plus 1, already told, that is 4. And array look like this. Here name of array starting index is, that is -1, and last index is, that is 2. In between you have 3 elements, 1 2 3 and 4, total 4 elements, and address of first element is given here, that is 100 byte. It is asking number of elements in an array. Total number of elements or size of element arrays, that is 4. Already calculated, upper bound minus lower bound plus 1. And now it is find out the address of first index element is, you know already, formula base address plus I minus starting index, that is known as lower bound, multiply by size of an array element. That is, here base address is given as 100 plus you have to find out the address of first element, that is 1 minus, here starting index is minus 1, multiply by size of an element is given here. It is basically integer. If you want to take the size of integer is 4 byte, then it is 4. Then address of first index element is 1 plus 1 multiply by 4, that is 100 plus 2 into 4, that is 108. Okay. Next, if you want to find out the address of third index element, then base address is 100 plus index is 3 and starting index is minus 1, multiply by base total size of element is 4, then it is 100 plus 3 minus minus this is 4 into 4, that is 1116. Similarly, the address of minus 2th index element is base address is 100 plus minus 1 minus minus 1 multiply by 4, that is 100 plus minus 2 plus 1 multiply by 4, that is 100 minus minus 2 plus 1, that is minus 1 multiply by 4 minus 4, that is means it is not possible to find out the address of minus 2th index element because base address is 100. Okay, so this is all about the address calculation of particular elements in one dimensional array. This is the references where I have taken from where I have taken the data. Thank you for listening.